this is just a very quick video because I fixed a bug in my game that I think was caused by a very common misconception about what vertex buffers are, because in every tutorial, also in mine, I have to admit, there you see code that is like the one I'm going to show you now when it's done loading. Yeah, so here's my draw triangles, and in this method I'm creating my vertex buffer, my index buffer, setting the data, and then eventually drawing it. And because you find code like that, I think a lot of people think, okay, my vertex buffer is just another object. But here's the issue why this is different. You can see I am not creating a vertex buffer here. The point is, the memory for the vertex buffer is created on the GPU. So if I have my CPU here and my GPU there, and this is my CPU memory and this is my GPU memory. So every time you create a vertex buffer object on the CPU, what the CPU gets is the handle to that object. The handle is maybe that big. But on the GPU, the amount of vertex data you said you need is allocated. So this much. And so if you create a new vertex buffer object, you get a bit of overhead because it's a .NET object and it has additional functionality and all that. But essentially you allocate memory on the GPU. So if you create a vertex buffer every frame, this is what happens. That's on your first frame, that's on your second frame. Then here's your third frame, which goes on to, let's say, there, fourth frame, and so on. And at some point, your graphics card will be out of memory. And when that happens, the GPU will wipe some stuff out. It will take some memory regions and say, okay, this hasn't been used in quite a while, I will throw that out. But that takes computation time. And until this happens, the .NET framework still has some sort of valid objects that point to the memory region on the GPU. So what I did is, I'm not sure if this is the most elegant solution, but that's what seemed natural to do for me, is I declared vertex buffers here when I knew their size. There is a class dynamic vertex buffer which I will probably use later, because right now the way I'm rendering sprites is not very elegant. But the thing is, I have my map vertex buffer and my map index buffer, and my map does not change. So I'm having these buffers which are static, I'm calculating them, and then I just leave them like that. And that seems alright because my map doesn't change and all that, but for my sprites I do the same thing. So here I set the vertex buffer on the device to null because I want to change the data of my sprite vertex buffer. The thing is, if the GPU is set to render from this area of memory, then I cannot change it. So I need to set it to null so I can change the data, and then I set the GPU to, or my device in that case, to use that memory region. That's what set vertex buffer basically does. And same for the index buffer, I have to set it to null, and then I draw. And for that reason, I do not use all the memory on my GPU, but I just use a very limited space. So the way I noticed that I have a misconception here was that I thought my game was garbage collecting, but that wasn't true. So it took me a lot of time to figure this out. But in the end, I profiled my program and I saw that the garbage collector wasn't running because I had everything set up so that my garbage collector doesn't or isn't triggered at least until very, very, very late because I'm caching a lot of stuff. I'm allocating everything in my loading routines basically, so the garbage collector shouldn't run. And even if it ran, it shouldn't take a long time to do that. So I was very confused because sometimes my game would just stop for like a second or 2 seconds, and that was when my graphics card needed to wipe memory free because I was constantly allocating new memory, and that didn't happen until like 1.5 minutes into the game. But at that point, I would have my next rendering calls would have to set or to transfer the texture data to the GPU again, and everything that was kind of cached there because the GPU just wiped the memory clean. And that's all. The thing is, if you're using a vertex buffer, just create it once and set the data every frame if you like, and just draw it then. But do not create a new vertex buffer every frame like I did. Thanks for watching.